you've written a lot of books, and you've written a short introduction to superconductivity, a short introduction to magnetism, I think. And here's your most recent one, Quantum Field Theory for the Gifted Amateur, where you say in the back, quantum field theory is arguably the most far-reaching and beautiful physical theory ever constructed. So there are quite a few books out on quantum field theory, including other introductions to quantum field theory. Tell us a bit about this one. Why did you feel you needed another book?
So this book, which I've written with Tom Lancaster, a colleague at the University of Durham, who used to be here in Oxford, what we tried to do when we were writing the book, it was partly because we're both experimental physicists, and we've both wrestled for a long time with trying to understand quantum field theory ourselves. Partly because we needed it in our research, mainly because I think it is a beautiful theory and something that, it's a mountain, it's like Everest, it has to be climbed. We tried reading a lot of books on the subject, and there are some wonderful other books on the subject, but they are all written by quantum field theorists, and therefore experts who are writing essentially for trainee experts in their own field. And we just felt that there was nothing really that bridged the gap between where a physics student would come to at the end of a quantum mechanics course, an undergraduate quantum mechanics course, and moving on to these more advanced topics. So the title, Quantum Field Theory for the Gifted Amateur, was a little bit of a tongue-in-cheek title, because it's not it's not for the complete amateur. The gifted bit is important, and I suppose we like to think that we ourselves were gifted amateurs, certainly amateurs, and we hoped for gifted. But that was really the idea, to write something that was that brought a bit of the fun back into quantum field theory.
It's a very technical subject.
It's a very technical subject, so it can be quite a slog, and we wanted to try and do something that first of all filled in a lot of the details, because quite often in these books you go from one step to the next, and somewhere a miracle occurs. We would often find we would take one of the other books on the subject and try and work out how to get from equation 2.11 to 2.12, and it would take, after an hour you get it, and it would be wonderful to have worked that out. But we really felt that for a lot of readers they would want to see things spelt out a little bit more.